Tanya Rowling, helping you to solve Maths, CBSE Class 10 NCERT syllabus, and my sister Tina Lofus would be teaching CBSE Class 8 Maths NCERT syllabus. Alright, now let's get into the video. Today we are going to be learning Euclid's division algorithm. We are going to be following its certain steps and we are going to be learning its definition. Okay, first of all, now let's focus on its definition. Okay, so this is the definition. To obtain the HCF of two positive integers, say C and D, with C is greater to D. Okay, so this is the Euclid's division algorithm's definition. So here, if you want to get a HCF of a particular value, for example, two positive integers. Okay, for example, you can just take 4 and 5. Okay, so for obtaining its HCF, first we just take the greatest number and the smallest number. For example, let me show that. For example, you have 4, 5. So in the question they might have mentioned any values. Okay, for example, in the question if it is mentioned 4, 5, then first of all you are supposed to find the greatest number and the smallest number. So in these values, which is the greatest number? So in these values, the greatest number it is 5 and the smallest number is 4. So you can just put the greatest number sign. Okay, so why? Because the 5 is the greatest number, 4 is the smallest number. So as you guys know, 5 is the greatest number. You are supposed to write the greatest number inside and the smallest number outside. Okay, so in division, in this we are supposed to write the greatest number inside and the smallest number outside. Okay, so that is the main topic and the main process they are talking about in the definition. Okay, so as you guys can see in this, if you want to get a HCF of two positive integers, first of all we are supposed to write the greatest number and the smallest number. Okay, so just now we did the same thing and after that we are supposed to follow certain steps. Okay, now we are going to be following its steps. Okay, so this is the step number 1, that is apply Euclid's division lemma to C and D. So we find the whole numbers Q and R. So we are supposed to apply Euclid's division lemma. Okay, so Euclid's lemma means Euclid's division lemma to C and D. So to C and D means we can just take any values, but we are supposed to take the values mentioned in the question. Okay, so in the question itself they might have mentioned the values. By using the values we are supposed to apply Euclid's division lemma. So after that what we are supposed to do is we are supposed to find the whole numbers, that is Q and R. So what is the Q? So Q means quotient and R means remainder. Okay, so after applying Euclid's division lemma to C and D, that means the values, then we will get a quotient and the remainder. For example, let me show that. So here when we just did this, so I am just dividing it. For that, for example, first you will have a value, that is 4, 5. In case if we have value 4, 5, you are supposed to find the greatest number and the smallest number. So here I am just writing like this, 4 and 5. So in this, which is the greatest number? So the greatest number is 5. So you can just put the greatest number sign. So here 4 is the smallest number. You are supposed to write the greatest number inside and the smallest number outside, like how I had written it right over here. Okay, so you are supposed to write the greatest number inside and the smallest number outside. Okay, so now we are supposed to apply Euclid's division lemma. Now let's apply that. So you guys might be confusing, in Euclid's division lemma what are we supposed to apply? So we are supposed to apply its formula. Okay, so now let's write its formula. So the formula is A is equal to B into Q plus R, comma 0 is smaller to R and R is smaller to B. So this is Euclid's division lemma's formula. Okay, so here we are supposed to apply Euclid's division lemma's formula in both the 4 and 5. So in the steps now they had mentioned C and D, but here for example we just took it as 4 and 5 as a value. Okay, so we are supposed to apply Euclid's division lemma in 4 and 5. So how are we going to apply it? So after finding the quotient and the remainder, so whatever remainder it is, So as soon as you get one remainder, you should stop it right over here. Okay. So here we are supposed to use the formula or apply the formula, that is A is equal to B into Q plus R, where 0 is smaller to R and R is smaller to B. Okay. So according to this formula, we are going to be solving it. Okay. So in A value, we are going to be writing 5. So of course you guys know what is the A value. So we just take dividend as A and divisor as B. Okay, so this is the divisor and this is the divided. We just represent it as A and divisor as B. Okay, so I had explained it to you guys in the previous video when we just focused on Euclid's division lemma. Okay, so do watch that video. So here what is the A value? So the A value it is 5. A value it is 5 is equal to what is the B value? So the B value it is 4. So we can write the 4 and here it is B into Q. It is in the multiplication form. So we can just put the multiplication sign and we have Q. Q means quotient. So what is the quotient? So the quotient is 1. Okay, 1 as it is, and write the plus and we have R. R means remainder. So the remainder is 1. Okay. So we just put the values according to the formula. You guys might be wondering what about these things. So these things, we just use these things for a rule. Okay. For now we are not going to be using it. Later on when we get into the exercise now, that time we can just use it. Okay. So when they just ask to find the 3q value, like those things. Okay. So when you just get into the exercise, you guys can understand for what purpose we are just using this. Okay. Okay, now we get 5 is equal to 4 into 1 plus 1. Okay, so we just applied Euclid's division lemma, that is this formula, and we got certain values by using the formula. So now let's focus on the step number 2. This is step number 2. If R is equal to 0, divisor D is the HCF of C and D. If R is not equal to 0, apply division lemma to D and R. So here R means remainder. Okay, so if the remainder is 0, then we take divisor as a HCF of C and D. If the remainder is not 0, then we are supposed to apply Euclid's division lemma. So if the remainder is not 0 means instead of 0, if we get some other numbers like 2, 3, 4, whatever numbers it is. So whatever numbers we get, we are supposed to apply Euclid's division lemma to D and R. So we are supposed to take the next value, that is R. So whatever remainder we got it in the first place, that one we should take, and the D. D means the divisor. Okay. So for example, so you guys can see here we just applied Euclid's division lemma and we got certain values. In these values, the remainder it is 1. Okay. So do you guys remember the step number 2? According to step number 2, if the remainder is not equal to 0, that means like numbers like 1, 2, whatever numbers it is. So if the remainder is not equal to 0, then we are supposed to take the remainder and the divisor. So here B means divisor, am I right? So here we are supposed to take the divisor and remainder for doing the next step. Okay. So after that, what will we do is we just take the greatest number and the smallest number for doing this, like this division again. Okay. So we write the greatest number inside and the smallest number outside. So likewise we just continue it and finally we will get the remainder as 0. Then you should take the divisor as its HCF. Okay, remember that you are supposed to take only the divisor as its HCF in case if you get the remainder as 0 in that particular division. Okay, but in this division I got the remainder as 1, so I am supposed to continue this step. So for continuing this step we need values, am I right? So for taking the values we just take the remainder and the divisor for doing the next division. Okay, step number 3 is continue the process till the remainder is 0. The divisor at this stage will be required for HCF. Okay. So of course you guys know that they are supposed to continue the process again and again until we get the remainder as 0. So as you guys know, here we got the remainder as 1, so we are supposed to continue it. Okay. So after continuing, after doing the division again by taking B value and the R value, in the previous things whatever values we took, no, in that we are supposed to take the B value and the OR value for doing the next division. Okay, so in the next division, in case if you get the remainder as 0, we are supposed to take the HCF as its divisor. Okay, so in that particular division we will have a divisor, so we just take the divisor as a HCF. Okay, so these are the main things I would like to say, because this is really important. Okay, so finally, of course, you guys know we are supposed to continue the process until we get the remainder as 0. Okay, so but finally we will get the remainder as 0. If you get the remainder as 0, you are supposed to take the divisor of that particular division. Okay, so these are the things I would like to say about Euclid's division algorithm. Okay, so it was somewhat confusing, but when you just get into the exercise, you guys can understand what I would like to say. Okay, so in that first question we have 3 subdivisions. Okay, so in that 3 subdivision we just use Euclid's division algorithm. So after doing that, you guys can get an idea about what I am trying to say. Okay, so finally we just know what is Euclid's division algorithm. Thank you guys for watching this video. Please like, subscribe and help your friends by sharing this video. If you have any doubt, you can comment me in the comment section. Catch you in the next video. See ya.